Okay. So my mission today was kind of to give a overview of computer vision, how to get started, and what tools do you need for it. So I'm assuming that the people here have some idea of how a deep neural network works, and they know a little bit of Python, and all of the links and everything you're gonna see ahead, assume that you know a little bit of both. If you don't, reach out to me. I will provide you more beginner-friendly links. So to go back to the beginning, what is AI? So artificial intelligence is a big world, a big word, but you have to remember that it all comes back to this idea that you have a function that you are going to try to approximate, and that function corresponds to reality. And what do you mean by approximating a function? It means that we're going to model everything as if it was a mathematical function. So for instance, you are hearing my voice right now, and the voices and the cracks and the words in my voice, they can be captured with a function. The probability of you agreeing or disagreeing that everything's a function can be modeled via a function. How well you're going to perform in school might be predicted as a function. So it all comes back to this idea. And if we can break this down, we're going to put the predicted y, and we can make it more clear that we're talking about functions. And when we have it written like this, it gives us two things. We have this like sigma value, which we call parameters. So when you hear, oh, that deep learning model has 1 billion parameters, that's what they were referring to. And also, we're going to battle back to the concept of a feature. So a feature is truly anything that can be measurable and is a property of something. So let's suppose that we are trying to collect information about what type of chocolate people like. If they like black chocolate, or if they like white chocolate, that could be a property. If they like chocolate with a percentage of cacao or pure cacao or without sugar, those are all features of the type of chocolate that we have. And typically we have two big branches in machine learning, and it's all about the way you learn. So in supervised learning, you have what you're trying to predict, and you have a response associated with it. So it's kind of like learning with a teacher. In unsupervised learning, you have your group of features, but you don't have a value that you're trying to predict. So my analogy is kind of like trying to learn with your peers and try to separate it. So for instance, trying to find words in my voice might be a supervised learning if somebody annotated word by word, but it might be unsupervised learning if I only provide you with the audio. So it all depends on like what type of data you have, and a test can be formed from one to another. And finally, what is computer vision? So computer vision, as it suggests, it involves computers and involves vision. And what I like to define it as the computer vision teach computers to see. And everything that involves seeing what we as human beings perceive as vision. And typically it falls within the artificial intelligence realm, and it has a lot of overlap with certain fields, especially optics and robotics. So if you're trying to teach a car how to self-drive, then you're trying to teach a car, essentially, how to see. Or if you have a laser, or in the medical domain, if you have magnetic resonance machine, then you might be teaching artificial intelligence how to see human beings or organs inside of that machine, or not inside of the machine, using the data that's coming out of the machine. And it also has a big overlap with natural language processing. So that's kind of where we are at. And today we're going to talk a little bit about this intersection here between computer vision and image preprocessing. So what does computer vision actually do? Like what are the things that we can teach computers about vision? And I think we're going to first start with like the classics. So the first is just to have an image and tell you whether that image has something or not. So if you take a picture of a beautiful kitten like this, you can just build a classifier that tells you if this is a cat or if it's a dog, and then it's going to see the image and it's going to be like, that's a cat. The second level is kind of you look at individual pixels in an image and tell like, okay, it's a cat and the cat is here. And we call that segmentation. The third is object detection. And object detection is just saying there's a kitty inside of this box, and there's another here in this box, and another here in this box. And the final one is actually a mix and match. It's saying there's one kitty here and giving you the specifications. There's another kitty here and give you the precise like coordinates. So instant segmentation is nothing more than object detection and semantic segmentation. But modern vision is much more than that. So if you go to the Hugging Face Hub, they have a task page, which is just about tasks. They are divided by domains, which is this link. I'll give you the presentation later and you can go straight there. And you can see that modern computer vision actually can do a lot more. So there are the classics, object detection and image classification. But for instance, a new way to do is to take one image from 2D and make it into a 3D, which is like what we call depth estimation, or what is like what is the, I guess the hype right now is to generate pictures by asking the computer to do them for you. And that would be more like unconditional image generation or just image generation in general. So, oh, it's a shame it's not loading. But my question is, what is a feature for an image? So a feature for an image is going to be different than an image in a tabular data, because images for your computer, they are matrices. So instead of having a database that you're pulling information from, you just have one big matrix. And you could think that each space has, I see that somebody asked if we can get slides, and yes, you can get the slides later. You could think that each line in each row could be a feature and an observation, but then you're going to lose the spatial information that you have. So to teach a computer how to see, you need to teach it how to find features. And as I told you, this is matrix. It also means that you can play with computers just as you would make, like, play with matrices on your computer. So for instance, this is a dark image, and then you can think, I'm just going to subtract a little bit from all that, and you become a lighter image. And when you do this, I think it's a lot like playing with Instagram filters when you're trying to edit your photo and make a super cool picture. And you can do that with Python, like just with programming tools. I put the links here below. And you can make that link directly with the distribution of the pixels for each image. So for instance, you have an image with very low contrast. It means that the histogram of the pixel values is squished. And if you want to enhance into things, you just literally take the histogram and pull apart, and it's going to enhance the contrast of that image. So next time you play with Instagram, just think that you're doing something like this, either automatically or voluntarily, and then you can do the same thing with Python. That also lets you a very simple thing, that using those properties, those small properties that we have on the histogram, we can separate, for instance, a background and a foreground, and we can just have a mask of whatever is in here. And all that falls into the real one, what I'm called pre-processing. It's like you're just manipulating a matrix on your computer, and there's no AI to it yet. But it's important to know that this exists, because that's what or how we first try to generate features for images. For instance, here's an edge. An edge is a region of the image that there are color changes. So if you take the original picture and you do an edge filter or edge detector, it's going to output an image like this. And there are different ways to do it. This is the one that's called SIFT, which is supposed to be invariant to a lot of transformation. So if you turn the picture upside down, or if you rotate it, it's going to find the same features all over. And that's what you see here. The tutorial to how to generate this and how to do it, it's in below. And that's how we used to do in the future. We used to extract this, make an image into a database, and from the database do some traditional machine learning techniques. The good news is that it works and people still use it to this day. So this is a paper that came out in 2020, so 4 years ago. But they were comparing modern neuronal networks to those features that were handcrafted. And they had a lot of success doing handcrafted features for this magnetic resonance. And here's just a simple example. Here you have a picture that has been thresholded, so everything that's greater, for instance, -4 is going to be 1 and 0, and that is enough for them to find interesting things in their pictures. And I'm telling you this because if you have a small data set or if you have a small problem with your data, doing this helps a lot. And especially if your user is still interacting with an image instead of just a label, that can be really helpful to give them access to these things, just like kind of we have access to the Instagram and we can change the luminosity. And all of that, all of this pre-processing classical image manipulation, they can be found in libraries such as the OpenCV. I think the OpenCV is a really good place to get started. It's really widely used in the industry, and they have a free bootcamp. Anybody can enroll. It takes about 3 hours to finish it, and it's you're gonna hit the ground running and know a little bit more about classical computer vision and image pre-processing there. So I told you this is the classic of the old school thing. Now I'm gonna tell you about the modern things. So the really revolutionary thing about neuronal networks is that you do not need to handcraft those features. And everything that's more modern in computer vision is going to follow kind of this idea that we are seeing here. We start with an image, and then we have a first network that's going to be a backbone, and they're just going to extract features for you. So it's going to just do the process of getting from the image into a database of features. And from those features, you can either enhance it or you can skip this altogether. And you're going to put a head on top of it that's really good in a task. So either like really good at object detection or image classification, or you're going to build your own head if you need to and you have labeled data, or if you have a proxy or you're going to try zero sheet, whatever it is you're going to try. You're going to put the head there. And then you're going to have the output that you want. And the nice thing about like this modern stack is that there's an API that already can do it. So you can check it out on Google Colab. That's the link that I put it here. And there you can try this. And then you can change the backbone, you can change the neck, and you can change the head. And it can be really helpful when you're trying to build a new model and you don't have that much data. Or you're not doing this for the sake of doing this. You just want to fine tune somewhere. So that's a really good idea. And what I wanted to talk about is what I would consider the key ideas in modern computer vision, which is just going to be convolutional neural networks. And also we're going to talk a little bit about transformers, some of models, some of the heads that you can plug. So like YOLO, and we're going to talk about segmented anything. And I think I also put clip. And then I'll lead you to more links if you want to know more about that. So convolutional network is a classic in computer vision, really classic. And it's really what allowed us to actually get like traction into the field, because before this, people were kind of skeptical about neuronal networks and how would neuronal networks work with computer vision. And it's based on convolutional layers and pooling layers. And here they can repeat several times. They can have smaller blocks or bigger blocks. That's going to depend on your actual neuronal network architecture. But the idea is that those layers do operations that are really interesting to us. So we're going to dig deep into that. So if you get what is going on here, you're going to get what is a convolutional layer, because it's a big name. But what it actually does is take one image. We're going to imagine that this right here is an image, just like the image we saw in the beginning. And it's going to look within a neighborhood. And what it's going to do is going to pass a filter, which would be the values of this thing here, in the thing that moves in orange. and it's gonna multiply that by a given value, and it's gonna sum. And that's the value that you see that's gonna come here, what they are called convert feature. And the trick is that because neural networks are capable of doing that process where they're going to go back, they're going to update the weights, you don't need to have this filter made. It's going to start with a random filter and it's going to be updated. And over time, you end up finding a new feature in your neural network. And that's very different how we used to do things because we want to, before, before neural networks, researchers used to build this by hand. So in edge detection, for instance, you would have a filter that's going to be 101, and that would detect I think that's a horizontal edge. I always get those two mixed. And now that you don't need to do that by hand, you can build lots and lots of features and extract lots and lots of features. So that's really the key, the really key pinpoint precision of convolution. It's a simple operation that allows you to pass information from one image to a feature automatically. And it really doesn't matter. For instance, here we are imagining I have a black-white picture, but on the classical, you have red, green, and blue. You can do the same thing. You can pass those filters along those different channels, and then you can sum them. Here, we're adding a little bit of a bias to a final output, which then you can use to classify. And the really nice thing about this feature is because we don't want to lose information in specific points, we pad our our original image with zeros. That's to guarantee that the output will have the same size as before, and we won't lose information around the edges. I heard somebody's mic. If anybody has a question, you can interrupt me or sending on the chat later. Otherwise, I'll keep going. Um, And the next key point is about pooling layers. So pooling layers, they are a way to reduce the dimension of your data. So instead of always processing this, you can imagine it's a 300 by 300 or 16 by 16, you reduce them. So here, for instance, you're doing max pooling, which means you're doing the same operation as before. But instead of learning the parameters, you're doing it by a function. So it's going to look at in this neighborhood and it's just going to put here the max value. So with those two elements, it's all there is inside of a neural network. You have a convolutional layer and an activation function, and then a pooling layer, and then you have another block of convolution and ReLU with another pooling layer, and that's how your convolution learns all the way until you get to your head where you're going to have your main task. If you want to go to more details, the place part of the pictures, it goes a little bit into the fine tunes of it all. And the second idea is about vision transformers. And vision transformers, I think they're super cool. And nowadays you also have convolutional vision transformers, so you can have both words. So the idea of transformers is that you go from an image and then you can break it down to patches. And then you essentially pass these patches through a transformer encoder, and you pass along with their position in the original image. And from the transformer encoder, you have your multi-layer perceptron head, and that's going to tie back to the head that you have for your model. It sounds a little bit fuzzy like that, but what we're going to see is that this process here is really what allows it to be promptable and what it allows to share information. So it does that thanks to the transformer encoder architecture. So the transformer encoder architecture, this part in the middle that seems kind of magical, it's also composed of essentially 4 blocks. And those 4 blocks are the norm. So the 2 norm blocks, essentially what they do for the architecture is they stabilize learning. So it's just normalization of the layer. The multi-head attention, it's what allows the embeddings to communicate. So here you have each attention head not talking to each other, but trying to see something in an image. And then the perceptron allow them to like reflect, essentially to think independently of one another. And then the zeros is what it's going to help them to communicate with each other. So altogether, what it really does, it teaches the new network to see something in an image and what is a part of. So if you go heavy into the encoder part, then you need to talk about carries and you need to talk about keys, but we don't really need to do that because visually, what we can see is that if I have a head that's looking for essentially like a fluffy or a dog, it's going to focus on this part of the image. And if you had something that's talking about leaves, it's going to ignore the snake, it's going to ignore the background, and it's just going to focus on just like this leaf part. Same thing with the plane. So here you could say you have the sky, you could have the, how do you call it this in English? A cloud, and you have the plane. And in your head, it's only going to be able to identify the plane. It's going to look only that. And it does that because we patch it up so it's able to reconstruct it together. And yes, so again, just to give you the proper name, it's called an attention map, and it just teaches you what, it shows you what the network's looking at. The sad thing about transformers is that in order to have good transformers, so those here are the ones that are more accurate on top, you need to have lots and lots and lots of data. So if you want to use transformers, you probably want to use a pre-trained model. You don't want to train the transformers from scratch. Okay. So now we have the main ideas. We know what a transformer is. It's just a way to teach an architecture that teaches the model where to look at. And we know where convolutional layers are. We can talk about specific models. So first is, I think it's important, is CLIP. So CLIP is contrastive language image pre-training. And what it does, it takes a text encoder and an image encoder and tries to match both of them. So if I have a text that say that's a pup, like an Aussier pup, that's the breed of the pup, and then I have a breed here, when they match, I'm going to have a high value. And then once you have that, you basically create a classifier for that label text and use that to create a prediction. So let's suppose I'm trying to find a picture of the dog. I would say I want a photo of the dog, and then the text encoder is going to try to find where that match, or the vice versa. Well, actually, an example is the vice versa. So you have a picture here of a dog, and then it's going to look, essentially, the image decoder is going to be the same as before. It's going to produce those embeddings, and those embeddings is going to try to find the closest one. And when it finds the closest one, it goes, okay, that's a photo of a dog. So essentially, it just embeds the text, embeds the image, and then try to match them on this imaginary space. And I give you some links. So here's the GitHub for it, and here's the model on the Hugging Face. And if you want to try this for yourself, go straight to the Google Colab. The other one, I think it's a classic, it's YOLO. So YOLO is not you only live once, it's you only look once. And what's good about YOLO, that it starts with this really simple model, which is essentially several convolutional layers with maximal layers, and now we know what that means. It does that several times, and it was designed to only look through the image once, so to be super fast, super accurate. It was designed for object detection. But modern YOLO can do much more. It can do classification, detection, segmentation. It can do tracking. Tracking, the difference between tracking and segment and object detection is tracking is usually the word people use when you're doing video or pose estimation. Pose estimation, I think it's self-describing. And YOLO is really well documented. So I also put some links for you to try it out. There's, I think, the latest one is YOLO version 8. And it's really, really well documented, and it's really super fun. They have tons of resources available on YouTube, on their GitHub. They're really great at that type of tutorials. Finally, another model that I think it's very relevant is the segment anything model, which is called SAM. So SAM, it's both a task, a model, and also a data set for image segmentation. And what is cool about it is that it's supposed to be all licensed and private respecting images. So if that's a concern for you, that should be something that you can use. And it's also designed to be like promptable, so you can try it without retraining or anything. And what it does, essentially, if you have a picture of a dog, it's gonna segment like we see before everything. So different dogs, so it has different colors, and even different years of the dog have been segmented. And it's a really simple model too. When you look at high level at the architecture, you have an image decoder that produces the image embedding. So just like our transformer vision model. And then you have a convolutional operation here, where essentially what it does is helps here where we're going to try to break down from your decoder and the prompt decoder. So here, this is really helpful when you're trying to prompt the model. So you're going to try to say a picture of a dog, a picture of a house, or whatever it is that you want a picture of. And then it's going to give you masks, and they're going to also score the validity of that. So, and you can also change the neck if you need to, like we seen before. I also leave you with the sources, so you can either go to the Hugging Face Hub, where they have a lot of resources and you can see the demo for the segmented knitting model. I also recommend you checking out the GitHub by the Facebook research people. Pretty cool. And also give it a Google Colab so you can try it out. And last but not least, I don't think I could finish this without talking about the modern computer vision, which is about image generation. So this is a video. It's not super good. It's a bit creepy, but it has been completely generated by AI, and I really like it because it shows you that like the model doesn't really understand how sauce works. Like it moves in such a weird way and it bounces back. But these models are usually based on the idea of diffusion. And Hugging Face has a course that just came out on fusion models. So go check that out if that's something you want to learn. And then there's also a community-led computer vision course that should be coming out soon. But the GitHub, you already can access it if you're really looking forward and enthusiastic about reading more. And lastly but not least, because this talk was focused on what you need to be a computer vision engineer, it's not only about building computer vision models, you need to serve them and you need to get to the people who actually need to use them. And for that, you need to find a way to deliver those models. So this is much more than I can talk about. There's a lot of different ways and different strategies that you can serve models. Here's just a couple of the platforms that you can do that. And I actually recommend if you're interested in accessing the Medium post where it talks more about that. And talking about Zoom camps, I know that the Data Talk has some free Zoom camps that you can sign up yearly. I think they do once per year. But even without the Zoom camp, the resources are available. And I think they have 2 or 3 weeks where they talk about serving models on the machine learning Zoom camp. And next month also they starting the MLL Ops Zoom camp, which I think I'm also going to take because I'm interested in learning more about that. So I also recommend it's 100% free. They have a community on Slack, and it's really fun. And lastly, if you have more questions, something that's not clear, if you need resources that are more beginner friendly, if this is something you already know and you need to learn more, you can always reach out either by email or you can also talk to me via LinkedIn. You can keep it up with whatever it is I'm doing on GitHub. And lastly, I have a newsletter that highlights women's achievement in data. If that's something that interests you, you can also subscribe to it. So I hope that satisfies your questions about how to get started with computer vision, what computer vision is, and what are the tools that are available out there for it. And I know it's really fast and a lot to take in at once. So if you have questions, okay, I see a question from Israel. I hope that I'm pronouncing her name right. How long does it take to understand computer vision? How much dedication do you have to understand it? I think it really depends. It depends if you're just trying to focusing on one specific application or several. I think that understanding just on a high level, you just want to understand what it is and how to get started. and you already know how to program and you already know a little bit of machine learning, I think under a month you can really get yourself going. Could you recommend pages where we can train our computer vision models, more specifically YOLO V8? Pages, do you mean you want tutorials or do you want resources to train it? Like, do you need something that has a CPU or a GPU? If you need resources, I think Google Colab is one way to do it. I have a paid one that I use to train more heavy duty models that I cannot do in my computer, which is Paperspace. But Paperspace, it's paid, but it's not super expensive. It's under 9 euros per month. And if you want to access, I guess, more specific high performance GPUs, you pay for it, but it's not too overpriced. Otherwise,
Yeah.
yes, go ahead, Danielle.
So I think a lot of people have questions and they just want to go ahead to drop the questions with us. So if you have a question, I would appreciate if you can just raise up your hands and so we can
Mhm.
coordinate it. Or if we've not answered your question, can you just raise up your hands, please?
Um, Another less traditional way, I guess, to try to get GPUs is to sign up for competitions that they give you hours of training. And then if you win or if you reach the participation level, you can also get some resources from that.
Yeah. Oh, no one asked question. Did you answer the questions? Um, can we get slide? Oh, someone's looking for a slide. Someone's
Oh,
looking
yes.
for.
Sorry. I'm going to go ahead and just stop sharing my screen and share with you guys the slide. So, um,
Okay. Chukwudi, I think Chukwudi has a question.
I'm going to send you over here.
Chukwudi.
It's
We can't hear you.
Can you write down your question maybe? Because it was echoey and
Like
we
when
couldn't
you're
hear.
through with learning it and you're now ready for work, is it? I don't know if it needs a certificate.
Okay, let me answer that question.
Um,
So he's asking, um, he's asking like when you finish learning computer vision, do you need certificate to get a job? You get
Oh,
what I'm saying? So I'm gonna tell you like I've been doing computer vision for very long and I don't have any single certificate, even from Coursera. Sounds funny, yeah, but that is largely because I'm from Africa and dollar rate in Nigeria is a whole lot. So if I have $400 in Nigeria, I'm very rich. I can pay my house rent for 2 years. If I don't pay my house rent for 2 years, I can feed for 2 years. If I don't feed for 2 years, I can do a lot of things with $400. $400 is like 500K, 500,000 naira. So and this is something you pay for just one course. Some courses ask you for like $1,500. That's 1.5 million, 2 million naira. So what I did was I utilized YouTube. Everything I do in computer vision is YouTube. And on Coursera, I audited courses. So I audit course a lot. So
if you
I
need a
I use course.
certificate on Coursera, you can actually apply it for a discount too.
Yeah, you can apply for it, but I
Yeah, so
made a
that's
mistake
another thing.
and I went to apply for 5 courses at the same time. And they gave me 5 of them. I didn't finish at the same time. So I lose everything. So how do I prove to myself and how did I get my jobs that I'm doing currently? How did I do it? So there are ways you can literally do it without a certificate because obviously I'm thinking like an African, we don't have money to pay for these stuffs.
But
So
even
what
from like data camps, there's courses, they have certificates and they are all free. Same thing with Hugging Face. All the courses are free. And if you want to get the certificate, You just have to train a model and you submit. And if you reach a certain threshold, I don't know it by heart, but they are also free and they also give you a certificate. So that's something that, like, if you think you absolutely need a certificate, you can get a certificate for free.
Can
Yes,
you drop
sure.
the link?
It's on the hiring phase. It's on the learn. I don't know if all courses have certificates, but I know some of them have. And then the
Isabella,
data.
you've dropped so much link. Yeah, I need you to join the community. So you just be dropping them.
um, yeah, but
So
I do understand. I think that if, especially right now, I think that there are a lot of companies selling a lot of education in AI. And okay.
yeah. But what I do, you know, I've not got any certificates, none. So but what I do is that I literally prove my skills. So I prove my skills using LinkedIn. I prove my skills using boot camps. I prove my skills using sessions. So instead of going ahead to show someone that I have the certificate, I'm now going ahead to show you that I can prove I can solve your problems. So I build a project, and when I want to build projects, I don't just build project because I'm bored or like doing something like, oh, I built a software to detect broomstick. No, I build a software that solves the problem, like that solves someone's problem. You know, so I literally build projects and post it on LinkedIn. That's how I landed my first job 2 years ago. I'm doing till now.
Mhm.
I post a lot of projects. Like, so when people see your project and they see how competent you are doing this, they now know that, yeah, you are specialized on this and this is what you can do. And they now reach out for you. I had my interview on phone call. I didn't stress myself because they were looking for me so much because I proved myself. So you utilize the social media so much, utilize LinkedIn, utilize Twitter, post your projects, do things. And then another thing you can do is, instead of applying for jobs, solve a problem. And that's what I did with Dalens AI. The day I launched Dalens AI, I got another job.
Mm.
So
And I think I have also another question from Iani Kai.
yeah,
Um,
I'm not saying a question.
he has his hand raised.
Okay. Actually, I raised my hand up.
Oh, okay. Go ahead.
All right. Yeah, thank you, Daniel, and thank you, Isabella, for the presentation, especially the source video that's AI generated. It was actually pretty interesting to watch. So my question from software engineering background,
Mhm.
like I'm looking from your presentation, I'm kind of highlighting like to actually start this computer vision journey. So like, is there open source communities, programs that I can contribute to? Maybe if I learn a couple of things and I can just contribute some of the things I've learned, my skills to some project-based sources. You understand?
Yes.
So just
So-
okay.
Okay, yes, I get it. I also understand the pull for open source. It's pretty cool. I like it. So one that I would recommend for sure is the Hugging Face Computer Vision community. You can join by joining the Discord. The community computer vision course was made entirely by people in the community. So you learn a thing or two, you can start contributing to the course. Well, the course was more about teaching, but if you knew a little bit, it gets you far. Um, what I Other initiatives that I think are cool and open source, I think it's the Scikit image and the Napari plugins. So the Napari is more focused on biology, but what's actually this is a viewer, and if you have more software engineering playground, I'm going to drop the link for Napari and Scikit image. If you have more of a software engineering background, I think you can actually contribute to making those things nicer. Um, yeah, I think those are cool. If you're more interested in 3D vision, I know that Open 3D also has a community, but it's a little less active than those other two. Um, I think those are the ones that primarily come to mind. But do check the Napari. I think you're gonna like, especially the plugins, because then you can just even if you're just connecting, a library that already exists into a tool like Naperi, that already makes such a huge difference for people who don't come from machine learning background.
All right, thank you so much. Yeah, I'll look into the links. Thank you so much.
No problem. And also, if after looking at the links, it's not clear, don't hesitate. You can come back to me. I think Daniel wants to speak again. Sorry,
Yeah,
Daniel.
yeah, yeah. I just have this passion for like people solving the problem we have on hand. Yeah, I know we need jobs, we need jobs, we need jobs, but I think it is time we look around and we look at the problems we have around ourselves and we try to solve them.
Mhm.
So when you try to solve your problems, then I think money will chase you. Because if you can chase these problems that we have and you solve them, and you know, I'm not. Here's why you're laughing, but I'm serious. We have a lot of see, Isabel, Africa. That's why I invest in building a lot of startups. Like I just start right now to build. I build them. I scatter
Gotta
them
have
around
the
because
entrepreneur mindset.
we have a very big market in Africa. We have a very very big market,
Yeah,
and
yes,
artificial
get
intelligence is just
confident.
coming in. Computer vision is just coming in. So we are the best situation. We are the best place to become the richest guys in the world. We are the best place to become the richest country. We have a lot of problems that we can solve. And everyone that comes into tech in Africa all runs into fintech. They all want to make money. Everyone is now doing fintech, and all of them they're into web development. So that they'll get a job in UK and they'll travel and
Crypto.
leave the country.
I think
We don't
Tarika at some point had raised his hand and then he left. So I don't know if he has a question now.
Yeah.
oh
Hello, Isabella.
Hi,
Good evening. Yeah.
good evening.
I'm from Pakistan. This is Tariq Jamil.
Mm-hmm.
And I just
yeah,
want to
welcome.
suggest some good platform. Hello. Hello, Daniel.
Yeah.
So I want to suggest something because I have been practicing all these things for the last 3 years and gone through a lot many places and websites and platforms. And I just want to share the experience for the younger ones.
Yes, go ahead.
So at the moment, just as a background, at the moment I am teaching in the university deep learning also.
Mhm.
So that's
Wow.
great. Yeah.
Wow, welcome, sir. Welcome, sir. Welcome, sir.
Thank you.
Thank you. You are going to
So
speak next. You are
I
going to
just
speak
want to
next.
recommend one platform that is Omdena.
Oh
Uh,
yes, I love
yeah.
Undina too. I am part of one of their
Yeah.
projects.
So at the moment I am also their chapter lead at UAE chapter lead and launching projects sometimes. But at any given time, there are more than 10 projects ongoing at Umbrella in all over the world. So they have their presence in 75 plus countries, and most of the Africa and it is covered by the Omdina enthusiasts. And I have seen a lot many friends from Nigeria, Angola, and other countries, far off countries, and they are participating and they are learning, and then they are making some sort of startups also in their own countries. So you can open some sort of chapters in your own city or in your own country also. You just get them registered with them and just and submit some sort of project which you just aspire for, and then basically what they do, they publish that project on their website, and on the participants from all over the world, they basically apply for that, and you just make a team of around 50, and normally it gets around up to 30 people at the end. So you all collaborate with each other, you form a team leads, you form a task leads. So in a way, you work in a team, and at the end of 4 weeks or 5 or 6, there are 4 weeks to 8 weeks projects normally. So you learn a lot and you collaborate and learn. So I just and one more the other advantage is you normally get the subscription for the data camp or data quest at the end. So that is and their Slack channel also, they have a big community of their and there is Omdena school, there is Omdena's data camp channel, Slack channel. So there are 4 or 5 different channels you can always put any question out of their Omdena school is regularly holding many courses. Even you can also contribute to their courses. Also, you can opt for okay, I'm there to hold some course. So they will announce it on their website or their Slack channel, and people just apply for, and then so it's a big community. So this is my point.
Yeah, I think the nice thing about Adina too is that it's very much focused on AI for good.
Yeah.
So it does have a good energy. I also recommend that. Um yeah, I have only good things to say about Adina too.
Yeah. Thank you.
Wow, it's really nice. I didn't expect to see Tariq. What is his name again? I can't pronounce it.
Tariq?
Yeah.
Tariq. Okay, I didn't expect to see.
T-A-R-I-K,
Yeah.
Tariq.
Are
This
you
Tariq.
is
part of?
Arabic word basically.
Are you part of the community?
Yes, I am part of a Indian community.
I mean, the our community, Computer Vision Africa.
Yes, and in 3 4 days back, somebody flagged some WhatsApp channel invitation on augmented
Oh,
AI channel.
yeah, that was me.
So
That was me.
yes, so, so I joined through that.
Cute.
Wow, wow, wow. Wow. I'm really impressed. Like to see Isabella, to see you. Thank you so much for joining,
Thank
Tariq.
you. Welcome. You're welcome.
Isabella, thank you so much. Like I really appreciate it.
No,
Like
no problem. I like doing these talks. I like also building community and teaching others. So if there is ever another topic or another time, then don't hesitate to reach out. Or if you guys need help, or even if you have a project and you want somebody to reveal it, I am available.
that,
Maybe not so much in the upcoming months because I'm moving cities, but I'm generally available.
Isabella, I have a very very big like a very massive project. In fact, I think I have like 3 projects currently. I don't even know. I even want to give someone one. And I have a very big startup I'm trying to build. I'd love you to be part of it. Well, we'll talk about it later.
We can talk about it later.
Yeah. So
Okay.
so as I
Thank
said
you so much,
previously,
guys.
yeah, as I said
Thank you.
previously, you know,
Thank you, sir.
we need to find the problems in Africa, the problems in India, the problems in Asia, the problems around ourselves, and we need to solve it. See, I've applied for jobs. I've applied for jobs. I've not studied computer science. I've not gone to school. I studied electrical engineering, did national diploma, just 2 years, and I left the place because it was not interesting. So I've applied for jobs 40, 50. You get rejection letters. They'll be saying they need you to have masters, PhD, 50 years experience. You need to submit your mathematics certificate. You need to so I found the trick. The trick is solving someone's problem, proving your skill, knowing what you can do. And then to be good in computer vision, you just need to be you need to concentrate on it. Give yourself 3 months, give yourself 6 months, give yourself 1 year. So it will be now, this is the thing. You are gonna take 1 year to be good in computer vision, 1 year to know computer vision, to understand computer vision, and you take 2 years to be very good at it to land a job. I'm not gonna lie to you. Yeah, this is not web design. This is not mobile app development. This is something that your brain needs to go for it. You need to know a lot of mathematics. You need to know a lot of things. So the first 2 3 months is for you to be confused. You're gonna be confused the first 2 3 months trying to understand, and you're like, this thing is so hard. This thing is so hard. You know. And then after 2 3 months, it will now reset your brain because by that first 3 months, you must have known a little of mathematics, must have known a little of calculus, you must have known a little of linear algebra, all right? Then after that, you can now go into deep neural networks and to start unveiling. So in 6 months' time, you must have been done with your confusion. You must have been able to understand some basics in machine learning. Then after 6 months, you now start building stuff. That's when you now jump into computer vision. After that, you can now start building projects. So you need to start from image processing. You start from doing basic image processing with OpenCV. After doing all those, you now use those image processing technique to now build machine learning models, and that's what led to YOLO V8. So I see a lot of people from India. I interview a lot of people when it comes to that lens. I interview people a lot, and they only know how to use YOLO V8. They only know how to use. How do you know how to use YOLO V8? We cannot write TensorFlow models from scratch. You write YOLO V8 and you know how to use YOLO V8 very well. You don't know how to build YOLO V8 from scratch. That's because you jump the first two necessary steps. Your first 3 to 6 months, you jumped it into the next 6 months of building projects. You know, so that's what people get to miss. People get to miss these things. People get to miss these things. You need to be grounded on your basics, on your mathematics, or machine learning. It is when you do convolutional analysis that I now know about edge detection. um, 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 Vertical edge and horizontal edge, using matrices to work with convolutions to be able to detect edge with pure mathematics. This is how you start. I was telling one of my friends from India this week. I was like, bro, I know you are good at doing things. I see you do a lot of things, but I want you to go sit down, learn the mathematics behind these things, build them from pure math, because it is these guys that TensorFlow, that PyTorch, that Google, Amazon, IBM, they're looking for to work with them, and not just people that can use things. All right. So this is the little I can say. All right. I really appreciate you guys for joining. And I really want you guys to be very, very good. I want you guys to be the best of the best guys. I want Nigeria to be, when it comes to computer vision in Africa, artificial intelligence in Africa, we should do enough. And that's what differentiates India from every part of the world. Indians, they know how to make noise. They know how to make noise a lot. With the little they know, they'll go and scatter YouTube with it. Welcome to this tutorial. In this tutorial, we are going so they make noise a lot, they do things a lot, and they even make it to the point that the people that knows it so well will now overshadow the one that doesn't even know. And the one that doesn't know will come to YouTube and now do the wrong thing and will now be following them up and down. You see, as someone will use battery to power a whole house, because of the noise. So we need to also start learning, get very good, and then we start making noise. And that's what will push us out there. So Isabella, is like you want to say something. The way you are looking at me is
No,
like,
no, I think it's a very motivational talk, but I agree. I think learning in public is great. It also, like, you can look back on how much you learned in the past and be proud of yourself. Um, oh, I was just thinking about how Israel was like crying over how long it's gonna take, and just don't worry about it. I think as long as you're passionate and you keep working on it, it pays off in the end. Um, yeah, that's all I have to say. But yeah, do which one? You want to get a job? Get a job. Do you want to build a startup? Build a startup. Do you want to just do computer vision for fun? Do what's best for you. There are a million different ways to do it. A million different routes to go. Everyone has its own path. Just yourself. Everybody's be fine in the end. It's unavoidable. Um, you're all gonna be great. That's all I have to
yeah,
say.
yeah. I think Tariq, do you have anything you want to say?
No, I think Isabel is told enough. Only slide one thing. The Ultralytics website, that is the YOLO website, that has enormous number of examples and
Mhm.
tutorials over there. So
Yeah,
Yes.
if anyone want to excel in that YOLO side of the computer vision, they can always subscribe to their website. That is a great website, I must say.
yeah,
Yeah, I agree
yeah,
with that.
Yeah.
I think it's something they do really great. They have on YouTube, they have on Colab, on GitHub, that you can really get started with YOLO rather quickly.
Yeah, and even on LinkedIn, and they almost daily, Mr. Ridwan from Ultralytics, he posts almost one project on daily basis.
That was pretty cool.
So yeah, so
yeah,
you can join their channel also on LinkedIn. Yeah.
yeah, yeah. That's great. Wow.
Okay, guys, I have to go. But thank you so much for having me here, and thank you for all your input and for participating.
Yeah.
Thank you.
Thank you so
Thank
much,
Bye.
you.
Isabella. Thank you,
Bye.
Terry.
Thank you so
Thank you,
much.
everyone, for joining.
Bye.
I love you guys so much. Terry, can
Thank
I
you,
message
Daniel.
you? Isabella,
Yeah.
please join the community. Isabella, thank you. Isabella,
Yeah.
please join the community, Isabella. Terry,
Okay. Yeah.
no problem.
Thank you.
No
So
problem.
you can always join my LinkedIn channel. I will post that my LinkedIn connection over
Yes,
there.
yes, yes. Post it on the community. Yes, yes. So I can.
Thank you so much.
Thank you so much, guys. I love you guys so much. We are here together. We are here to grow. We're here to build each other until we get
Yeah.
to a better place and to get to a better country. I love you
Thank
guys.
you. Thanks. Thanks.
I'm gonna release the recorded. Thank you.